Hello everyone. In this video, we'll be solving problem number 26, remove duplicate from sorted array. The problem statement is, given an array nums sorted in a non-descending order, remove the duplicate in place. The relative order of the elements should be kept the same. Return the number of unique elements in the nums. The condition that is given to us is, we need to change the array nums such that the first k elements of the nums contain unique elements in the order they were present. The remaining elements of num are not important, so we can ignore it. And we need to return the number of unique elements k. Let's look at example number 1 to understand it better. We have 1, 1, 2. In this array, there are only two unique elements. One is repeated twice. So the output should be 1, 2, and the last digit doesn't matter. So it could either be left as 2 or we could replace it with something else. It doesn't really matter. And k's value will be 2. I hope you got a high-level idea about what this problem is asking for. Let's switch to whiteboard and understand this example a bit better so that we can figure out how it can be solved. Let's understand what this problem is asking us to do. For this input, the output should be all unique characters in the front. So 0, 1, 2, 3, 4. And the rest of the characters could be anything. It could be left as the original numbers, 2, 2, 3, 3, 4. This part will be ignored. If we compare the output to the input and see what was the pattern, whenever there is a duplicate number, we are moving the unique number to that position. So in this case, when we were looking at this 0, this is a duplicate number. So the next unique number was moved to this position. And this 1 was replaced. Now this 1 is no longer there. So the new state of the nums array would be 0 and 1. Now when we increment it again, pointer is at this position. We are comparing it against the previous one, which is 1, which is not unique. So this will be ignored and will continue until our pointer is at 2. This is unique. So this will be moved at index 2. Then when we are at 3, this will be moved at index 3. If you have noticed, we are now working on 2 pointers. This could have been solved easily if we were allowed to maintain a new array where we are just identifying the unique numbers and saving it in that and returning it at the end or replacing the original nums array. But the problem statement clearly suggests that we need to update the input array directly. While we were trying to understand the requirement, you may have noticed we were working with 2 pointers. First was pointing at the position where the unique character should be moved to, and the second one is to identify if the current number is unique. Let's simulate using this approach and see what logic we need to add to take advantage of 2 pointers. Starting with UP, unique pointer, as 1. We don't need to set the unique pointer to 0 because we know this number is always going to be unique. So as I is 1, i's corresponding value is 0, is unique. So we are comparing it against the previous number. So is it unique? No. Because it is not unique, we need to replace the value where this UP is pointing with the unique value that we'll stumble upon, that we'll figure out later. So I'll leave the UP pointer as is and I will increment my I. So I is now 2, i's value is 1. Is it unique? Yes. So I will move this value into the position that unique pointer is pointing at, which is 1. So this will become 1. And because I have already replaced this position and it is unique now, so I will have to increment my unique pointer. So my unique pointer will become 2. I will be incremented to 3. I's value is 1. Is that unique compared to the previous value? No. So we don't need to do anything. Just increment I. Again, the value is 1. It is not unique. So do nothing. Increment it again. At index 5, the value is 2. It is unique. We will have to replace just like before. So we'll replace the value to the position that UP pointer is pointing at. which is 2, this 2 will be moved to this position. So the new value will be 2. And now we'll increment our pointers. UP will be 3, I will be 6. The value at I is equal to 6 is 2. It's not unique. Similarly, we'll continue the iteration until the end. And once I is pointing at the last position and that run is complete, my output would look something like this. We can choose to ignore these characters at the end after we have figured out all the unique characters and moved it up. As we are running through the iteration, we can maintain a variable k and increment it whenever we stumble upon a unique number. So after this run, the value of k will become 5. The time complexity for this solution is O of n, where n is the length of the array and space complexity is O of 1, as we are only using this one variable to maintain the number of unique numbers. I hope you were able to understand this explanation. Let me show you how we can implement this simple solution using C#. I start by initializing a unique pointer, set it to 1, and the return value. This return value is same as k in the examples. Then I start my for loop with I starting at 1 until it is less than nums.length. If the number that I is pointing at is not equal to the previous number in the array, which suggests that the number is unique, I'm copying that number into the nums array that unique pointer is pointing at. After the copy, I'm incrementing the unique pointer and also the return value. After the for loop is complete, the nums array will have all the unique characters at the start, and the return value will suggest total unique numbers in the nums array. As you can see, this solution is very simple and it beats 100% of the submissions made on LeetCode in terms of runtime complexity. I hope you were able to understand this explanation and the solution. You can access this source code. The link is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.